axis is a name for a line. So it has a line of symmetry. There's also another type of symmetry called rotational symmetry. And that is when we spin something from the center of the shape. We'll look at that in a second, but let's talk about lines of symmetry. Give me a shape that definitely has a line of symmetry, somewhere where I can definitely fold it. Sorry? A circle, yeah. Definitely has loads of lines of symmetry. Ren? Square. How many lines of symmetry has a square? So let's look at a square. I could definitely fold it this way and this way, can't I? It would fold perfectly over and diagonally, yeah, Alex, yeah, I think so. A square will fold diagonally. Will a rectangle fold diagonally? Maybe. Oh, I don't want to do that. That's not. Maybe a rectangle will fold. Let's try it. So I'll take a little vote. Many people think a rectangle has 2 lines of symmetry. 1, 2, 3 people. And many people think it has 4 lines of symmetry. More, okay? Well, definitely if I fold it this way, that's perfect. And if I fold it this way, oh, that's perfect as well. So that's 2. If I fold it diagonally, what's going to happen? Is it going to fit? Yeah? Yeah? Sure? Pretty sure? No. That's Oprah. That's not. That is not perfect. No, it doesn't. It only has 2, unfortunately. So a square, yes, and that's all about angles. But a square has 4 lines of symmetry. So something I might ask you to do in an exam is draw the lines of symmetry. So we'd use dotted lines for lines of symmetry. A rectangle only has 2. I'll draw a little rectangle here, just this way and this way. Some triangles have lines of symmetry, don't they? What type of triangle would have 1? Equilateral has how many? Alex? Cone. Cone will have a line. It's a 3-dimensional shape. I'm just thinking about 2-dimensional at the moment, yeah, but it would have a line of symmetry, correct? An equilateral triangle would have a many. So an equilateral triangle, which is a triangle that has all the same lengths of sides and angles, has how many lines of symmetry? 1 definitely, yeah, I could fold it here. That it? But if you turned your head, wouldn't it look the same sideways? Now I know this is my sketch, but it would. If it's an equilateral triangle, it would actually have 3 lines of symmetry. An isosceles triangle would have 1. Okay. Let's talk about rotational symmetry then. Spin a shape from center. Right. What does that mean? Here is the center of this shape. If I spin it, how many times does it look the same? Doesn't look the same yet. Is this the same? No, it's sideways, isn't it? Spin it around, get to 180 degrees upside down. Is that the same? That's the same. Okay, that's 1. So keep spinning. 270 degrees is here, not the same. And when it's fully back to its position, how many degrees is that when it's fully back? 360, full turn, yeah. Is it the same? Yeah. So how many? 2. The one at the end does count. So what can we say then about every shape? It has at least 1. It has at least 1, because when it finishes up back at where it started, it's the same, yeah. So it's called well, let's draw our shape first. We started off with I'll do a little sketch. Start off with a rectangle. We twisted it around. That was 90 degrees. No. We twisted it again. 180 degrees. Yes. We twisted it again. 270 degrees. No. And then we came back to the start. 360 degrees. Yeah. All right, so that's what the vision looked like. If you're putting it in your notes, that's what you would think. Put a dot at the center of the shape and see how many times it sits in position. This one has what's called order 2 rotational symmetry. Or you could sometimes say every 180 degrees, if you want. But I'll be just looking for the number for the moment, just order 2. We say every half turn or something like that. I'll just be looking for how many in a full rotation many times does it hit. Of our other shapes, square would have how many, order what? How many times have I spun it around? 4. It's in position 4 times. And this equilateral triangle, how many times did it sit in the same? 3, yeah. So quite often it's the same, especially for these regular shapes, it's the same answer, that they have the 3 lines of symmetry and a rotational of order 3, the same. Okay. Not overly complicated. I do have a little challenge for you now. In the other class, nobody got this challenge, correct? So this is, I'll get rid of this bit. I'm just talking about axial, lines of symmetry. I want you to go through the letters in the alphabet, draw them as perfectly as you can. For example, B here, sometimes you can draw a B like this, and that wouldn't have any lines of symmetry. But if I draw it perfectly, it would have 1 line of symmetry. You could fold it this way, yeah? And A would have 1 if I drew it perfectly. So 1 and 1. Go through all the capital letters of the alphabet and see how many lines of symmetry, if you drew them as perfectly as possible, each one has. And let's see, can anyone get 26 out of 26? I think the best yesterday was like 24. So give it a go. No, it's not for points. It's just for fun. What's the date? What is the date? It is the 14th of April. Yeah. All day. Okay, let's see, can anyone get 26 out of 26? Okay. C has 1. D, 1. E, yeah, all this way so far, all very straightforward. F, yeah, I don't think there's any way you could draw an F that would have any, so none. And G also, no, I don't think so. H? 2. All right, the first one with 2, yeah. This way, horizontally and vertically. Can I go diagonally? No, there'd be overlaps. It's a bit like the rectangle, so 2. I? 2. 2, yeah, same. 1 horizontal, 1 vertical. J? 0. Yeah, I couldn't draw it perfectly. K? 1. Yeah, it's definitely possible to get this one, isn't it? L?
0. I got 0.
If you draw this length the same as this length, there would be 1 diagonally. It would fold over that line.
Yeah, but L has a smaller tip.
I said, draw it as perfectly as you can.
Yeah, but normally
Yeah.
Exactly, and that's
It's not for, no, you want to draw it so it does have a line of symmetry. Okay, 90-degree angle, yeah, has a line of symmetry. All right, that's controversial, I know, but yeah, it's okay. It's not for points, don't worry. It's only just M. 1. N? Wouldn't have any. Kind of looks like you'd go along this line. Yeah? But this would fold crossways across this then. So it'd be backwards N if you did fold it the other way. It's not the same. Oh! 4. No, not 4. The only answer is infinite. You literally could draw circles all day as long as it goes through, or lines, as long as it goes through the center, you could fold that circle infinite times. So if you could be here for a while.
Why nobody let it in?
No, O wasn't the one. There's an even more controversial one that you're going to be more annoyed about me over. P. No. Q. Yes. If you drew it the way I drew it, you could fold it there, couldn't you? 1. Don't worry, that gets everybody every year, and everybody gets upset. It's fine. L and Q are my tricks. There's one other one that might be slightly controversial, but I don't think so. Or no way. S.
No, 1. I got 1.
If you fold it this way, this bit's going to go over here, isn't it? This bit, even if it's perfect, this bit's going to go over here and it's going to go this way.
What about right here? There.
Okay. If I fold it this way, this bit's going to end up here, yeah? It's going to be like curved like that, isn't it? Yeah, no, it doesn't work. Sadly, it doesn't have any. It is rage bait, yes. This T has 1 if you draw it perfectly. U has 1 if there's no tail on it. V has 1. W, you can draw it with 1. X.
2. 4.
4, yes. If you draw it perfectly, this one, and you could fold it diagonally if all these are 90-degree angles. So I drew it as best I could, like a plus sign if you keep turning it. All right, 4. Y, yeah, you could have 1. Not like mine, but if you drew this. And Z, none. Same thing as S, exact same thing as S. Where are you going to draw the line, and then it would fold over itself. Right.